Integrated fluid simulation. ZW3D has integrated a fluid simulation plugin for the first time, providing specialized fluid simulation tools for industries such as mechanical equipment and electronic devices. This tool meets flow field simulation requirements for products like valves, pipelines, and heat exchangers, guiding structural optimization to reduce flow resistance. It also supports thermal management simulations for electrical cabinets, power modules, and main control chips, aiding in thermal design to meet operational needs. Additionally, it offers an intelligent fluid domain extraction tool to simplify complex fluid domain extraction operations. Next, we will demonstrate how to perform a flow simulation for the valve. Click Simulation, New Fluid in the ribbon bar to create a fluid simulation task for the valve. First, create sealing caps at the valve's inlet and outlet. Then extract the internal fluid domain of the valve. Remove the valve's outer shell and sealing caps while retaining the fluid domain. Finally, generate an envelope domain encompassing the fluid domain. Assign water as the material to the fluid domain. Define the envelope domain material as a smooth frictional solid. Set the water material with highest priority in overlapping regions. Set the computational domain size to match the enveloping domain dimensions, and the probe positioned at the valve's center. Set the negative x direction as the inlet of the valve, with the inlet velocity being 3 meters per second. Set the positive x direction as the outlet of the valve, with the outlet pressure being the atmospheric pressure, and keep the default settings unchanged. Set the boundary conditions of other directions as the wall, and keep the wall parameters unchanged by default. Select the standard K-epsilon turbulence model and enable output of total pressure results. Configure 8-core parallel computing for the solver. Set the number of grids in the X direction to 300, the number of grids in the Y direction to 50, the number of grids in the Z direction to 80, and set the mesh size to uniform distribution. After submitting the calculation, monitor data in real time via the monitoring panel to assess result stability. The fluid domain of the valve is transparently displayed and the pressure contour of the cross-section of the valve is created. The results show a significant pressure difference between the front and rear of the valve, with negative pressure observed downstream. Generate a mid-plane velocity contour. Results indicate higher flow velocity near the wall on one side and lower velocity on the opposite side after water exits the valve. By creating a vector diagram, visualized flow direction within the valve, revealing a large recirculation zone downstream. By creating streamlines of the water flow, the flow path of the water flow can be seen more directly and the return area of the valve can be identified. The above is the case of valve flow simulation. Thank you for watching.